Assalamualaikum. So for today class, we will learn chapter 6, and this is part 1, just introduction to Intel 8086. Okay, before we proceed, let's take a look the evolution of Intel microprocessor. Okay, so for the first generations, as you learn microprocessor, you should know the first generation of microprocessor. Okay, invented by Intel in 1971. That is the first microprocessor in the world. Okay, it is 4004 and just 4-bit processor. Okay, just 4-bit processor. But for the first generation, between 1971 until 73, they come out with not only 4-bit processor, they come out also with 8 and 16-bit processor. And for the second generations, in 1973, they invented Intel 8085 8-bit processor. But 8085, they enhanced to 8-bit and 16-bit from 4-bit. Okay, and then for the third generation, during 1978, it is Intel 8086 and it is a 16-bit processor. So you will learn Intel 8086 and it is a third generation of Intel microprocessor. And for the fourth generation, during 1980s, it is Intel 80386, and for the fifth generation, Pentium. Okay, so this is overview about 8086 microprocessor. First 16-bit processor released by Intel in the year 1978. Okay, it consists of approximately 29K transistors, and it has 40-pin packaging in IC in the IP. Okay, and then it has 20-bit address to access memory, and it uses a separate 16-bit address for I/O map device. So even though you not cover for the I/O, so I just want to tell you this is an overview. It uses a separate 16-bit address instead of 20-bit address to access memory. Okay, 8086 separate 16-bit address for I/O map devices. Okay, so the main features you have to know is 8086 is a 16-bit microprocessor. It means that its CPU registers consist of 16-bit. And then it has 20-bit address bus. Okay, it will map or address to the 1 megabyte memory space. How does it get a memory capacity to 1 megabyte? We will look at later. Okay, as a programmer, so you have to know the programming model of 8086. Okay, because in the programming, we just concern the memory and the registers. Okay, because in the programming, we just transfer the data in CPU registers and memory. That's all. Okay, this is so for the general micro-P. Okay, general for microcomputer systems. This is micro-P, and this is bus system, and this is memory. So the memory data width size is 8-bit. So the data bus for the data 8-bit data. Sorry, the direction is supposed to be bi-directional because this is data. And address bus is 20 bits. Means your memory can start with 0 and final at 2 to the power of 20 minus 1. However, the address we don't represent in decimal, we will represent in hexa. So we will start with 0, 0, 0, 0, 0, 5 digits because 20-bit address. And final address is F, 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 5 digit. Okay, your data in memory can only consist 8-bit or 2-digit hexa. For the micro-P, so these are the registers. So we have many registers. We have AX, BX, CX, DX, SP, BP, SI, DI, IP, CS, DS, SS, ES, and flag. Some of the bits are not used for the flags. So dash 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 means not used. Okay, this is represent 1 bit for the flags. Okay, and then for AX, BX, CX, DX, the size is 16-bit, but we can use 8-bit separately. So let's say we want to use this one, AH. If this one, AL. BH, high, it means H high, L low. Okay, now how do you get 1 megabyte? Okay, because our address is 20, we have 2 to the power of 20 multiply with 8. So we get 1 megabyte. So that is the size of this memory. Okay, in your course, we don't concern more about the hardware part. Okay, but the hardware part, you have to remember, you have to understand well this part only. This is just introduction. As you know, 8086 40 consists of 40 pins. So these are the pins. So here is the clock. Clock supposed to be a pin out of a microprocessor. Okay, this is the architecture. Okay, even this we also don't care so much, but we need to know something that is related to our simulator. Okay, these are the registers and also registers. Okay, and then this flag register, ALUC, the LU is here, and this is your control unit. And this is an instruction queue. We call it as a pipeline. Okay, because of your register, 8086 register is 16-bit, but the address bus is 20-bit. So we have a problem to address the address, okay, of the memory. Okay, you can read this. Okay, so what we have to do. Okay, this is a register. Okay, I don't prefer to explain the register here at this moment because it's quite complicated to explain now. We will look at the register and its functions when we do the simulation. Okay. Okay, as I told you, our registers are 16-bit while our address is 20 bits. Okay, this one these registers and also these registers, it's in this category, and these registers in this category. Okay, for the BIU and EU. BIU is just for fetch the address and data, and execution unit EU for execute. It separates because it wants to be faster. These are the simulations. Okay, how we get the address? This is a physical address. Okay, this physical address is referring to the 20-bit address bus here. Okay, this address bus. Okay. So 20-bit physical address bus, what we have to calculate is CS. So where is CS? CS here. CS means it's not in this slide. You can refer to the books, chapter 3. So we look at CS. CS is code segment. Okay, code segment attributes points to the active code segment. Okay, page 20. So it will relate to the physical address CS. So let's say we have 456A. This is 16 bit. Okay, and IP. What is the function of IP? Same as program counter. It's point to the next instruction to be execute. Okay, same function as PC. So what you have to do, 456A, you have to shift to the left, so you can get 456A0. Just put 0. Okay, and then you have to plus with IP. Okay, and then so let's say I use calculator. Oops. Okay, I use calculator. Okay, already in my. Okay, 1620 plus 456A0. So you get 46CCO. This is the physical address. Okay. Okay, and then next, we will refer to the handbook topic 4 later. Okay, and then here, this is prefix for number bases in 8086. This is important to differentiate between the number we use, the number bases we use in the programming. So if you want to use the value in decimal number, don't put anything, just nothing here, just put the number. But if you want to use the value in binary, put the B after the value. For octal number, put O after the value, and hexadecimal number, put H after the value. Okay, we will continue to the. We are not start the programming yet, but I will explain in the simulator.